Okay, so a little variation here. Whenever you have a one of your factors of your denominator happens to be a quadratic term, then what you've got to do is you have to set them up as such. So on the first one, I'm going to have my numerator will have to be a linear term. This is always going to be the case. All right, so I'm going to call that ax plus b, and then that'll take care of one of the x squared plus ones. And then on my other fraction, it can be of the form also linear, cx plus d, and then you'll have a single. So you always, whenever you have an exponent, you have to have one of your denominators be that exponent, and then all the way down to an exponent of 1. So I really don't need a parentheses there, but I put it anyway. Okay, so now, all right, so on this then, let's multiply by the least common denominator, clear all that out, and we'll have us an interesting looking system. All right, so I'm multiplying everything by x squared plus 1 squared. Well, in that case, that's going to get rid of that because I'm multiplying by that denominator. And here, that'll go away. And then this will leave you with an x squared plus 1 because I'm multiplying by x plus 1 squared, which would have canceled out one of those and left me with another one because I'm multiplying everything by that denominator. All right, so I've got a little FOIL method right there. And so you end up with a really interesting looking system here in just a second. So I've got 4x squared plus x plus 4. All right, and then I have a x plus b. All right, we'll deal with that in just a second. And then on this right-hand side, I have to do the FOIL method because those two are getting multiplied together. So I'm going to do first. So that'll be a cx cubed all right, outside is going to be a cx. Inside will be a dx squared. And the last term will be a d. Okay, so looking over here then, my system, I mean, obviously, looks like c is going to have to be 0 because there is no x cubed. All right, but let's get the rest of it here. All right, so there is no other cx cubed. So that means no other x cubed. So c must be 0. Okay, and then let's see. Then from the quadratic, I have this. Dx squared would have to equal 4x squared. So that means d's got to be 4. All right, and then let's mark these 3 times. 2, 3. 1, 2, 3. 1, 2, 3. All right, so on the ones marked 3 times, I've got ax plus cx has to equal x. So that means that a plus c has got to equal 1. And that's that 1 right here. All right, then on the constants, we'll just say, we'll just circle those. All right, so those two have to equal 4. So d plus b has got to equal 4. But we already know some of this stuff. All right, so previously we said c is 0. So if c is 0, a's got to be 1. All right, and then if d is 4 and d plus b is equal to 4, then b's got to be 0. All right, so then here is our partial fraction decomposition then. So a is 1 and b is 0. So I've got an x over x squared plus 1 squared. And that's because a was 1 and b was 0. All right. And then over here with the cx plus d, we have c of 0 and d's got to be 4. So that's a squared right there. And so this has got to be, if d is 4, then it's just going to be 4 over x squared plus 1. Okay, and that does it. So type that in and away we go.